Look, the given diagram shows four processes, that is isochoric, isobaric, isothermal and adiabatic. The correct assignment of the processes in the same order is given by ADBC, DACB, ADCB and DABC. Clearly, process A needs to be isobaric and process D is isochoric. Okay, so D should the option should start with D. So A is gone and C is gone because isochoric is first. Okay. Oh wait. Isochoric is first. Yes. Okay, I'm right in that. Okay. So should start with D, isochoric. Okay. Now among between B and D, options B and D, where is isobaric? Second. Okay, so DA is there, DA is there, so it again boils down to should we consider B as isothermal or should we consider C as isothermal? Okay, now to decide that, first of all let us recall the equations for isothermal and adiabatic processes. This is isothermal and this is adiabatic. Okay, raise your hands if you understand that. Okay, and look, this gamma being the ratio of specific heats has to be greater than 1. We have argued that. We argued about that here. Okay, earlier in the theory part. Right? Because when we supply heat at constant volume, then what happens? Whole of the energy that we supply is utilized to increase in the temperature. Because volume is constant, there is no P delta V work. But when it is at constant pressure, both are involved. Heating also takes place and change in volume also takes place. Okay, so gamma is greater than 1. So what we can do is, to simplify things, let us take this point as 1, 1. Okay, look, we are now converting it into a mathematical problem. Okay, suppose we take this point as 1, 1. Okay, let me take it here. Okay, now my pressure is Y and my volume is X. Okay, so xy equal to constant is my isothermal process. Okay, xy equal to constant. Now although I know that gamma values are quantized or fixed, I can, for analysis, I can take any value of gamma which I find convenient just to prove it. Okay, because we are now solving it as a mathematical problem. Okay, look, V is X, so let us take it as x squared y equal to C. I can do it, right? So basically I'm taking gamma as 2, but that's fine. What I want is it should be greater than 1. And if I want this point to be 1, 1, let us take this as xy equal to 1 and x squared y equal to 1. So I'll make sure that both these curves are passing through the same point which is located here. Okay, now look, isothermal means y equal to 1 upon x and adiabatic means y equal to 1 upon x square. Now after 1, 1, can you tell me which curve will be closer to x-axis or v-axis? X squared, because larger the value of x, even greater will be value of x squared, therefore smaller will be the value of 1 upon x squared. Have you understood that? Right, for example, if I take x as 2, okay, let's complete the proof. Suppose I take x as 2 here. Isothermal would mean y as 1 upon 2. Isothermal would mean y as 1 upon 2. So that means somewhere here. But what about adiabatic? Adiabatic would mean y as 1 upon 4. Okay, so this is 1 upon 4 and this is 1 upon 2. So this is isothermal and this is adiabatic. Okay, isothermal, adiabatic. So isothermal is B. Isothermal is B, adiabatic is C. Okay, so which option? Third is isothermal. No, second is isothermal. Have you understood this?
Yes, sir.
Yes, so, well, I have seen most students remembering it. Like, if the first point is there from which the two curves originate, then adiabatic is always the one that is below the isothermal. Okay? Okay. And what about the processes that end at the same point? Okay, let's say we have something like this. Okay, and suppose I have two curves like this. Now can you tell me which one of them is isothermal and which one of them is adiabatic? Think about it.